So, all this stuff. Orange, black, black, orange, brown. I don't have the faintest idea. Darn it. Hello, I'm Robin Vincent and welcome to Molten Modular. We are back at the DIY bench and today I'm going to be building the Befaco Chopping Kinky. What the heck is that? It's some kind of wave folder, I think. In fact, I'm not entirely sure. I'm hoping to find out by the end of this build exactly what it is that it does. But it's a kit that Befaco sent me to build, and I'm going to use it as an opportunity not only to make an extraordinary video about the building of the Chopping Kinky, I'm going to use it as a little bit of practice before my imploding Descartes' dream build. So I'm not going to mess about, no long introductions. Let's grab the instructions and see how we do. Well, first of all, as far as I can tell, the instructions seem to match the online ones. So I'll stick with the online ones for now until we hit a problem, as we inevitably do. But they appear to be the same revision, and the ones online are a little bit more colourful, which might help me picking out some of these resistors. Now, what we got? We've got a bag of resistors for the main board, and a bag of trims and bits and pieces. And then we've got two more bags for the control board. Bag A, stuff in it. Bag B. Oh yeah, very exciting. We have two boards then. This one and this one. Control board, I think, and main board, I think. It says the smaller one. So, I mean, they're the same size. Duh. So I guess it's this one that's had a bit chopped out of it is probably the main board. And this one, because it has the big holes for the switches or whatever's, it's probably the control one. I don't know. I'll see what occurs once I start getting into it. Otherwise, I've got a bunch of ICs, and then a bunch of knobs and sockets and stuff. But there's quite a few things to do here. I've got two boards to solder, got quite a few components. This should take me a good couple of hours, I reckon. And I don't know that I've got enough solder for all that. I've only got a little bit left in there. So that might be a problem. We shall see. I've got my soldering iron fired up over here. I've got useless clipper things I never use, bits and pieces. I think I'm more or less solder sucker. I think I'm more or less ready to go. Anyway, so it says the main PCB, the small one. So by process of elimination and resistor count, I think it's going to be this one. Let's do this one. So let's grab bag A, which is here. Casually empty it onto the table. Ooh, things. Let's not let them roll away. Some more lumpy bits. Just the resistors. That's where we're going to start. Right, there should be 27 of value 100Ks. Well, there's going to be 27 of them, and this is just in bag A. No, I'm not. I'm in the wrong bag. I'm in control board bag A. Alright, right. Okay, so let's open the right bag, shall we? Main board, bag A. That's what we want. Good gracious me. So, all this stuff is here. Now, this is a bit more like it. 27 of those. What's the bedding? They are brown, black, black, orange, brown. Actually, pretty much like the other ones. That's definitely the stuff. So let's put all these in. So there's 27. That sounds like a good load of stuff to, what's the word? Solder. So here's our thing. Just got to find the stuff. Now, if you're familiar with my videos, you'll know it takes me a little bit of time to warm up. As in, the first couple of bits are just really stupid. And I don't really know what I'm doing. And then I make it up. And then I go, oh yeah, I'm doing this. And then it all starts to kind of miraculously pull itself together. Look at that. Okay, R1, mission accomplished. All right, well that's a start. This means it's sort of soldering time, doesn't it? But that's fine because I'm an old pro now, so all I need to do is get stuck in. I just need to actually pick up the soldering line and do it. It's always a tricky first bit. Right, okay, stick them all down, get soldering, stop talking. So the moral of this particular story, at this time, is not to put so many things on the board at once because you get stuck with the legs. Yeah, I just put solder in a hole that didn't have anything in it. You nitwit. Right, well this is rocking tonight. No, I haven't got to that one, and I've just cut it. Right, I'm going to solder that one quick before I lose it. You see, every time I do a project, it's a learning experience. I learn new stuff. Some stuff I've probably already learnt and then forgotten about, which is why I wanted to do a practice build or another build before I start on the decal stream, because I didn't want to make all those same mistakes. I want to make the mistakes now. Mistakes like putting too many things on the board, so you can't solder them because of all the legs. R13. So part of the aim of this build is to make it as efficient, quick, less mindless chat. I mean, if you like the mindless chat, then I'm sorry about that. There'll be plenty, I'm sure, as I can't quite help myself. Certainly between bits. But just to get the sort of the slog work done, I just want to be as focused and as fast and as smooth as possible. That's great, and it's working out. It feels like it's working out. It's just chomping along, chomping ahead. Just got a whole load of resistors on, no fuss, no mess. Well, really, not very much anyway. That's feeling good. The print on the board is excellent. I mean, it's small, but everything is good. You not only get the component number, you also get the, the diagram, the image of it as well, for extra assurance that you know it's the right thing that's going down. And I find that sort of thing incredibly useful. I mean, some kits you get do come with all of the resistors labelled, all of them labelled, which is nice. But no, not this one. Not this one, but that's okay. It gives us something to do. Right, apparently I got 25 of these little fellas to go on. And all these fellas here, and here, and here, I think. So have I learned anything? Why don't I do a row? Do it that way. That might be the best way to do it. I don't know. Let's give it a go. Now, with diodes, obviously, you have to make sure they go around the right way. Which is the right way? Well, what sort of English is that? You've got this here. The black end is, I can't remember which end, but it's the black end, right? The black end, that goes with, on here, the little stripe, and that's the right way around to do it. It's probably a more technical term. I've had sort of positives and negatives, those sorts of things, but I'm just going to go with matching that up to there. Magic. Now I have these other two diodes on Z1 and Z2. Oh right, they've got proper diode symbols. There, Z1, Z2, right, great. So this time the black line has to go to the line on the diode indicator thing. Uh-oh. Uh-oh. That's it. That's all I've got. Oh dear. I don't think I'm going to make it to the end of this board. I was hoping to finish this board tonight. Got some more solder turning up in the morning. Although I do have some lead-free stuff knocking around. Maybe I'll give that a go. Oh, I know. I know what you're thinking. Oh, that's never going to work. Keep telling me. Even though I did my first. People went up into a drawer up there. How did that happen? Right, what am I doing? Okay, diodes, good. That's that entire oh, shit. I've still got 2 left. Oh, there we go. I almost screwed up. Then, okay, 2 more. Let's get these in here. Right, now onto the ICs. Oh yes, but of course what that really means is IC holders. This is something that I tend to struggle with, rather, because of the whole turning upside down and things falling out and not getting that quite right. So let me just do this one first. That seems to be in. I seem to be able to turn it over all right. Do I? Yeah, that's still in, I think. I'm just going to go for it with that little bit of solder that I've got left. Now I need to hold it a little bit flat so that I can make sure it's flat. See what I mean? This is always the problem. So I'm going to need to stand it up on, I know, I need to put another one in the other end. So if I put one here, one of these small ones, then it will be flat. You get me? Yeah, it's going to sit flat. Good. Give that a go. People generally recommend you do corners first. Let's give that a go. So, oh, see, I don't want it to tip. That's one corner. That's another. So hopefully those are flat. Yeah, good. Right, let's do the whole row of it then. There's some ones there that could probably just do with a couple of extra bits. Right, so I'm going to break all the rules and go lead-free. Yeah, everybody told me off for using lead-free solder, but, you know, it worked. It worked. I'm not saying it was easy, but it worked. So hopefully, so will this. So let's just have a look at the bit that I messed up, which is there. See if I can get this to melt. Alright, well, first test is to stick it on the actual end of the thing. Okay, it did just about melt. So there we go. And it was this one here. Yeah, you see? It's fine. It's completely fine. It's just a bit, maybe a little clumpy. Right, so that's 2 of those fellas on. Let's see if I can fit some more. Let's try these 2 in the middle. Yeah, they fit nicely. put those down, get stuck in. So yeah, there we go. That's a good place to stop, I think. That's all the ICs done. There's 3 left over which will go on another board. I won't actually plug them in yet. I think I'll solder the rest of it before I do that, to save me blowing them up or something, some such. Now the lead-free stuff, yeah, it is very different. It's more difficult. It doesn't melt so quick. You find yourself pushing with this, pushing against the leg you're trying to solder, and then it starts to bend, and then you're trying to do this, and it just gets a bit awkward. So yeah, I'm definitely noticing the difference between the lead-free and the leaded. But the stuff I've got turning up tomorrow is the regular leaded stuff, hopefully good quality stuff. I don't really know what I'm buying, I'm just trying hard. So that's great, that's 2 hours, that's almost one board done. Almost. I've only got a whole bag to do of trimmers and capacitors, and I'll pick this up another time. Right, so we'd got this far. This is as far as we'd got most of the way through the first board. I now got to add the capacitors and trims and other bits and pieces. Now, I've just taken delivery, if you've been watching my general feed, of all the components for the Descartes Dream build I'm going to be doing. There's like 4,000 components. There's a whole box full. And I was kind of concerned by the fact that this little layout here has taken me 2 hours. And so the enormity of the building the Descartes Dream just is getting out of reach, getting out of hand. So what I thought I would do now, I'm going to stop talking to camera, stop thinking about that for the moment. I'm just going to focus on the soldering to see if I can speed solder this and finish this board in the next hour. Just this little bag of bits. I've got some trim Watsits, I've got a bunch of capacitors and some things and a Watsit. So this should be easy. Oh yeah, those transistor type things. Triodes, great. The other thing that happens is I ran out of solder. I've now got a nice little reel of solder here, and this is narrower than I've had before because I'm thinking ahead to the surface mount that I'm going to have to do on the Descartes Dream. So this is 0.7 something. I don't know, millimeters, inches, who knows? I don't know. I'm making this stuff up as I go, but this seemed to be about right. There we go. There we go. That wasn't too bad. That was 25 minutes, half an hour, to do the rest of that board, which included, oh, I don't know, 30 components. Is that one component a minute? I don't know. Maybe something like that. But yeah, good. Yeah, got into a groove there. This solder is fantastic. It just flows really, really well. You know, compared to the lead-free stuff I use at the end when I was doing this last, and even the leaded stuff that I used up to then, because it was thicker, it took longer to melt, whereas this just flows. It's in there the whole time. That's great. I'm going to put a link to this in the description. I can tell you it's called Sine Multicore 6040 tin lead, diameter 0.28 or 0.7 millimeters, 5-core solder M7, because that's the sort of thing that would have been useful to me. Because I had no idea. And this is just bought off Amazon. It's not bought from a posh shop or a crazy place that I don't understand. I just go solder on Amazon and went through a few pages going, I don't know what I'm supposed to get, and it's nearly all lead free on there. And then, I don't know, this seemed to be right. It's leaded, it works. I've got a little fan over here in case anybody's worried about stuff. Worked beautifully. Beautifully, that word. So that's done. Great. Right then, PCB number 2. This is what they're calling the control board. So as before, I'm going to attempt to do all of this without really any further comment. I've got a bunch of resistors. I've got some diodes like that. A couple of these things, which are going to be what the other board plugs into. And a little handful of capacitors. The only thing of excitement is these two little ferrite beads, little tiny things here, which I have to solder on using a spare leg that I've cut off something else. So I mustn't forget not to throw all of the legs away, because I'm going to need a couple of those. I'll put those to one side. So I'm going to get stuck in, and I'll see you when it's done. Damn it! I seem to be missing a component. As far as I can tell, I have one of these little capacitors, and there should be two. There should be two, C100 and C101. And sadly, I only have one. I'm going to go back through my footage to see whether I did actually have it when I emptied the bag and it's now wandered off, or whether it was never there in the first place. Oh dear, that's frustrating. In all the kits I've done so far, I've not yet had a piece missing. Dear. So I'll stick this one in anyway, and then maybe I can move on with the rest of the kit. Don't know. Yes, probably. And then come back to soldering this later. So I've done the lion's share of what's required on this board, including the standoffs, power connector. This is all ready pretty much to marry up with this if I had it the right way around. That's going to go in together like that. However, I know I'm still missing a capacitor, so I can't do that bit quite yet. The bit that I do have to do is the mounting of the pots, potentiometers, onto here and onto the front panel. Kind of got to do this all at the same time to make it work. If you try to solder these without them being attached to the front panel, then it's not going to be even and it's not going to work, and it all gets a bit sort of desperate. So I'll try to do this as methodically as I can. LEDs are always trouble because they have to stick up through the front panel, so you've got to have that at the right height, and it varies per module how you actually do that. So this is what I'm looking at to now. So the long leg is positive, and now I've got to have my board this way up, because this is where the front panel is going to be going on here. So this is what we're talking about. So LED A and LED B, the long one is positive, that should go in there. This one, long one positive, should go in there. Not going to solder them because they need to stick up into that. Then the pots. Okay, so I'm just going to place them gently. So next up is all these little fellas. Darn it. So, attaching the front panel, adjusting the parts one by one until they fit. Yeah, right, all right, yeah. So the idea, or so it says, is that you're not supposed to solder them until this is kind of in. Aren't I missing a couple of these? I am, look at that. I've got 3 of these left. What am I doing? What am I doing? So it says mini jacks first, so let's do that. Good, right, bunch of rapid fire soldering other than the LEDs, which I'm going to leave for a moment because I'm going to need to go and get my kids, and that'll be the end of today's soldering. But with a bit of luck, I can get all this done if I go to town on it right now. So there is the front panel mounted of this Chopping Kinky. Still yet to explore exactly what that is or what that means. All needs a little bit of tightening up, but I have to go. Children are calling, school run and all that kind of thing. Right, where are we now? So a new day has dawned. I was up late last night sort of fixing things because I don't know if you recall, a few moments ago I was telling you about how I was missing a capacitor. But as luck would have it, I found the right sort of capacitor in another one of the kits that I haven't built yet. So I've borrowed that. Problem was that, of course, after I'd lost or discovered that that capacitor was missing, I just blundered on anyway. I just carried on installing things and soldering things, thinking, it'll be all right, I'll just have that capacitor later. That'll be fine. See, the problem with that, though, is that once I'd installed these pots, they actually go on the other side of the PCB. Capacitor goes on this side, pot goes on this side, and that went directly over the top of where the capacitor was supposed to go. No problem, because I can stick it in from this side, except the legs don't go through because there's a dirty great potentiometer sitting on the other side. Oh, what a doofus. So I encountered a little bit of a problem trying to get that capacitor into that space. Now I could, of course, unsolder, desolder the potentiometer, but that seemed like a bit of a faff to me. So I decided to go the other way around to work out a way of soldering the capacitor in place without being able to get the legs through the hole. So what did I do? Well, I pushed it really hard, bent the legs and pulled it and stuff. So what I thought I could do is that I could probably solder it from this side rather than the proper side. I could probably get away with that because there's no way I was getting a soldering iron in underneath the pot. So that meant having the legs a bit longer so that I could get to it. And so it looks a bit, if I get it under here, it's here. You see that? It's here. So there's the other one on the other side. That one there. That's what it's supposed to look like. You know, nice, flush up against that kind of thing. And here it is. Here it is. I had to have the legs longer because I needed to get the soldering iron in here, which was fine. And I think that's worked all right. The problem comes that when you then try to marry it up with this one, that capacitor gets in the way. So I've had to bend it at an alarming angle in order to get that to work. So I imagine that when we come to test this thing, this, if it doesn't work, is going to be one of the places I need to look first. And maybe I do just need to bite the bullet and desolder all of this. But is that another lesson learned? No, of course it isn't. I'll do the same thing again, no doubt. If I have something missing, I'll just blunder on and forget all about it. So where are we? Well, I just need, really, stick these things together, blah, 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 stick the knobs on, and then there's a bit of calibration to do. Oh, calibration, I really don't like that very much at all. I wish that when you built it, it was then just done. But no, you've got to faff around with tiny little screwdrivers and these little fellas here. So that's fun then. So I'm looking forward to that bit. So with everything installed now, I think, this capacitor and everything, it should just fit together. Put those pins up against those pins, like that. That's in, that's in. It's a little bit spiky. Push it together. Use these little things. Knobs. I'm assuming a bit like that. And a bit like that. Ow, and like that. She's done, look at that. That's lovely. I think that's lovely. So what does it do? I don't know. I do not know. I have a little power cable for it. Let's make sure that that sits in. Red stripe appears to be over here. I'm going to go with that. Yeah, okay, in, good. Rock and roll. So next job is going to be plugging it in, see if we get a light to work. There's LEDs and stuff, and then let's go through the calibration. Right, time to test, time to calibrate, or wherever else it is. So I've got a little bit of a rig here. I've got a scope, a couple of oscillators, and sort of, you know, general Eurorack bits and pieces. Let's just plug the cable in. Let's set it in the middle here somewhere. And let's see if some lights turn on. Oh, okay, I've got one light. One light's good, I guess. Is it? I don't know. Is one light good? Should I get a second light? I have no idea. Right, let's go with that and see what happens with the calibration. So we're now going to calibrate the VCA offsets of the internal analog switch to ensure that the noise floor is at the minimum. Okay, turn both channels waveform level knobs so they're at 0. I'm assuming that's these. Put them to 0. Turn both the attenuator level knobs to maximum. I'm going to have to assume these are attenuators, that's what's mentioned, and that these are waveform level knobs. You know, slight difference between the user manual calling it different things to what the assembly manual does. I don't know. So generate a square wave. So I've got a square wave coming out of my 3340 here into my O tool. That is pretty much 1 kilohertz, yeah? 1 kilohertz. Connect it to channel A's CV attenuator input. Like that. Connect the output of channel A to your monitors. Okay. Well, I have a little mixer here. I've got a high noise. Listen to the output sound and slowly adjust cal A1 until any noise is at a minimum. Now I don't remember last time I talked about the fiddly little screws and the trouble that I had calibrating the 3340. I actually found this tool here. I had it knocking around and it's got an end which is probably going to help this work. Okay, cal A1 is this one at the side here. I've got to adjust that until the noise goes away. Right. Listen to the output sound. Slowly adjust A1 until any noise is at a minimum. I don't have the faintest idea. I mean, it either sounds a bit like a sine wave or it sounds a bit like a sawtooth wave. See, I turn it down and then it goes back up again. There's noise, then it's gone. I don't know. Huh? Am I supposed to be making it 0? I have no idea. It really doesn't say. Any noise is at a minimum. Any noise, any sound, any what? Okay, at this point, I'm going to have to go and send Befaco a bit of an email to say, what? What is it all about? But before I do that, why don't we just plug something in and see if anything happens. Experimental plug-in. Right. It should be straightforward enough just to put a signal in to in A and get something out A. But I think I've got a problem. Let me show you. So I've got, what have I got? I've got a sawtooth wave from there going into A. The output, let's show this as stacked from A. Something's going on, but there's not really anything. Now what we should be hearing, so you should be getting that. Currently we're getting nothing. Get a little bit of movement on the scope, but not a whole lot going on. So that's a worry. Then I found, if I plug it into B, There it is. So it does work, at least in channel B. It's just that channel A doesn't work, which means I've stuffed it up somewhere. So I suspect that there's something in that side of things that's gone awry. Now, of course, fingers are going to point at that rogue capacitor. That's probably it. So I'm going to need to desolder that pot, take that apart and do that properly. That's probably it. What a drag. But there we go. That's what happens. It's the first time I've done a DIY module that's actually had a problem. And hopefully I'll come back in a few months and it'll be all sorted. Right, so update on that then. Calibration, that's easy. I'll do that in a minute. Thanks so much, Befaco. I've just, sometimes I could just be a bit clueless, and the little nudges along the way, it reveals everything. And now I can reveal that also. But troubleshooting. So I got me thing here, right? Here's my bleeding thing. I still got it plugged in. So I took the whole thing apart, right? And I looked through all the soldering, trying to find, where the heck is this problem going to be? I have no idea. I mean, I looked at that capacitor, the weird capacitor that I put in upside down, not upside down. I soldered it in from the other side, but actually that's channel B, so that's not the problem. So I thought, but I got the information through for the calibration, so I thought, sod it, I'll just put it back together, see what happens. So I put it back together, did the calibration properly, which I will share with you in a moment, and then thought, well, I'll stuff some audio through it. So I put it through channel B, that works fine. Put it through channel A, nothing. I thought, darn it. So having it in this state, of course, is all a bit kind of open and about to blow me up. So what happened was, I thought, right there is a little bit of signal. And so then I went to pull it out, and that happened. It's a bloody wobbly jack socket. See, that's something I can work out. I can solder that, I can fix that, and then I can show you the calibration, and then we can start folding waveforms, because that's what we're here for, the folding of the waveforms. Hurrah! Okay, so we're back again. This time we're going to have a look at the calibration properly. This time I now understand what it was all about. When they were talking about getting rid of the noise, making sure any noise is at the minimum, I assumed they meant noise in the signal as opposed to the signal itself being the noise. So in fact, what you're looking to do is to reduce the sound to nothing, because what they're testing for, what you're calibrating for, is interference going in to the CV input and coming out of the audio output. So you set the two top knobs to 0, the two bottom knobs to maximum. You take the output of your oscillator and plug it into the CV input, the attenuated, or at this point the boosted CV input on the Chopping Kinky. You then take the output and plug that into something you can hear. Now ideally there should be no signal going through at all, but this isn't a perfect world. But you go to the top knob calibration tweaky blue thing over here, and you turn it until it reduces to as near as 0 as you can get. Then you stick it in the other output and do exactly the same. You then, to test the analog switch in between the two of these, you take it and put it into the chop gate, which is the middle connection, and put the output into chop out. And that is how you calibrate the Chopping Kinky. So we've come this far. What is it? Well, the Chopping Kinky is a dual channel wave folder. What does a wave folder do? It folds waves like this. that beautiful? Works best with simple waves like sine waves. If you put in something more complex, then you don't really get the effect of the folding. It's with something simple like a nice sine wave that it folds that and screws it up, and it gives it this tonal quality that's a bit like a filter, but not like a filter. It's this whole West Coast idea of taking pure sounds and making them gnarly, of folding them and making them more complex. And that's what you get in a wave folder. Now I can't explain to you exactly why on the scope it seems to be offset to negative. I don't know why that is. It'll be something to do with my build, my calibration maybe. Who knows? At this point, I don't care. I'm getting a lovely sound and I'm going to go with that. There's also a little bit of noise in the background, some high-pitched stuff, which again I could probably calibrate out of there, but I'm just going with it as it is. Now in the two channels you've got two slightly different wave folders, so if we stick it through B, you should hear that it's slightly different. So it essentially generates a more interesting waveform. We could stick two in. Now once you have your sound being folded, of course you're going to want to modulate that. So let's bring in a bit of the to-me sine wave into here. Get that moving. Make another one. It's a B. Delicious melting of sound into one another. This it's not a wash, it's a goo. It's more like some kind of jelly being squashed and manipulated and pushed around as these simple waveforms get pulled and folded like a dough, like somebody making bread, like pushing yeast through something to make it grow. It's an extraordinary sound, a big sound. And this is all on a single note. You know, I haven't put a sequencer or anything, it's just chewing and chewing its way through this sound. But that's just two wavefolders. It can do something more than that. If you take, let's get rid of these two outputs, take a single output out of the chop out, that gives us something a little bit different. But the idea is that you switch between these two with a gate going into here, something going into there. So let's take a square wave out of the Batumi, and that should then switch between the two. So I've got modulation changing both the wave shapes on both of them, the wave folding. One is a kind of a sample and hold type, the other one is a smooth sine wave. All the time the two are being swapped from one to another. Because then I'd also quite like to stick that through a filter over here. And this neatly brings me to another possibility, which is that it doesn't have to be audio. It could also chop up, wavefold, your LFO. Why would you do that? Well, because you would then be making a much more interesting wave. Let me see if I can demonstrate this. All right, I've got this thing going through the Chopping Kinky. I've got the Batumi doing the filter. So if I was to put the LFO into B and put that into the filter, it's going to be producing a different sort of waveform. So you can see that our nice sine wave from the LFO has been wavefolded into something else. And I can use that wave-folded modulation signal to modulate something like the cutoff here. So essentially the Chopping Kinky can be used to fold waveforms of any sort, audio waveforms, modulation waveforms, whatever you like. You can start creating interesting envelopes or interesting sounds or interesting morphing of stuff all coming together. Or you can use it to modulate itself by wave folding the modulator coming in and then putting that modulator back into the wave shaper of the other one. So there you have it, the Befaco Chopping Kinky. That's been quite an epic build, not because it was difficult, just because I came across some issues of my own making and other bits and pieces and a little bit of trouble here. I've also been experimenting with camera angles and sound and other bits and pieces, so it's all been quite a good meaty learning experience. But as kits go, Befaco make good stuff. I mean, it's an enjoyable build. Things are small and tight in there. It takes a little bit of thought, a bit of concentration, more so than some other kits. But at the end of the day, you get something pretty special. And the Chopping Kinky is going to feel right at home next to my even VCO. And I imagine it's going to spread a whole load more movement through my rack. So that'll do. I'm going to shoot another video of just spending like 20 minutes having fun with it. So if you want to hear more about what it sounds like, go and check that out. But otherwise, I think that's enough for me. And in the meantime, go and make some tunes.